Hi, I'm Sam Powers, and today I'll be presenting CORA, a platform for continual reinforcement learning agents, work done with Eliot, Xing, Eric, Kolve, Roozbeh, Mottaghi, and Abhinav, Gupta in collaboration with the Allen Institute for AI. So we've seen a lot of success in recent years with reinforcement learning, but usually on the back of deep learning as well as large computes. But all of these methods have one critical flaw. They're not capable of adapting to new situations. If this hand with the Rubik's Cube were asked to pick up a mug, it would struggle. Our goal and the focus of our work is to move towards what we consider human-level embodied intelligence. So the ability for agents to be able to adapt to new tasks as necessary, to new environments as they come across them, and to existing environments as those environments change. We consider this the continual reinforcement learning problem, which we frame as a stream of tasks that are non-IAD and non-stationary. So say you're a grad student, as I was a few years ago, first year, trying to get started in continual reinforcement learning. The very first thing you might want to do is find an existing library that you can leverage. Okay, so as your first year grad student, you've given up on the framework that you're going to have to implement something yourself. So now what benchmarks might you want to use? So existing papers typically use Atari, which is great for demonstrating catastrophic forgetting, but because the tasks are very different from each other, they're not great at forward transfer. Additionally, the environments are pretty much always the same, so you can't demonstrate generalization. Also, Atari is pretty far from our goal of realistic household robots. If our goal is to have something more realistic, then Atari is a first stepping stone, but it doesn't quite get us all the way there. Okay, but Atari is what's been consistently used. So now you want to find baselines. So we have some existing baselines that have been validated on Atari, which is great. Unfortunately, there's no public code. DeepMind has not published the code for this. So as your first year grad student, there's a bit of a hill to climb. First, you have to implement these baselines. Okay, so now you might want to look at what standard metrics are available. Existing metrics either require more compute because they're comparing to single task, or they were designed mostly for toy tasks or supervised problems. So due to a lack of framework, a limited benchmarks, lack of open source baselines, and metrics that are not always the easiest to use, there's quite a high barrier to entry for your first year grad students starting out. This is why I present CORA, a platform for continual reinforcement learning agents to help address all of these problems. So we present benchmarks, baselines, and metrics. with the design goals of democratization, standardization, and moving towards future progress. So what do I mean by this? By democratization, we mean the ability for university-level students on university compute to be able to feasibly run the experiments. Standardization, we provide the open source code to allow for standard metrics as well as a standard sort of code base to get started with. And for future progress, a lot of work that has been done has focused on catastrophic forgetting, but we designed CORA with forward transfer, plasticity, sample efficiency, and generalization in mind as well to look at. So let's first talk about the benchmarks that we introduce. So the benchmarks we assume are n tasks that we cycle through m times with consistent action and observation spaces. And our goal is to be task agnostic. We want the methods that are implemented to not have to use task IDs. So the specific task sequences we introduce, we present the Atari method so that people can compare it to existing papers. That's 6 video games cycled through. ProcGen is similar in that each is a video game. However, ProcGen, since it's procedurally generated, allows for analysis of generalization as well. Minihack, because it's based on a video game from the 80s, is very fast to run. So we can run 15 tasks instead of the 6 for the other 2. This allows us to look at plasticity. Additionally, because the tasks for Minihack are quite similar, we can test for forward transfer as well. And finally, we introduced a suite of task sequences using AI2 Thor that we refer to as chores. And these are household tasks done in the first set by holding the task and object stationary or the same and varying the room, etc. Okay, so we've introduced a set of benchmarks that we believe expand what we can analyze with continual reinforcement learning. Next, we implement and open source a set of baselines. So elastic weight consolidation, which is a regularization method, as well as its online variant that doesn't require task IDs. We implement progress and compress, which is a dual architecture and distillation method. And we open source clear, which is a rehearsal method. These were all implemented using TorchBeast Impala, which is a fast asynchronous method, and allowing even people with access to only a single computer to effectively run these experiments. Additionally, we demonstrate state-of-the-art performance with clear, even beating what they presented in their own paper. We designed CORA to be extensible so that people can implement their own methods and use CORA effectively to hopefully add to our set of baselines as people develop new methods. And finally, everything has been open sourced on GitHub. Lastly, we'll talk about metrics. So the core metric is the continual evaluation graph. So basically, we train during the gray regions on the method, and then everything else is, while other methods are being trained, we can continue to evaluate the performance. So this allows us to see visually whether we're experiencing catastrophic forgetting, as we are with the bottom methods. And additionally, it allows us to look at generalization. So the dashed line here are the performance on the training environments, and the solid line is performance on the unseen testing environments, so that we can see, like in this case, clear, which is our pink lines, is capable of generalizing to unseen environments. And we look at these graphs across all of the tasks. So this allows us to have a comprehensive view of what is being learned when, and if we're seeing forward transfer or plasticity. So using these continual evaluation metrics, we basically get forgetting and transfer for free. And the way we do this is we evaluate task I before and after training on task J, where J is a future task. So this allows us to see how much J has caused forgetting in task I. Similarly, we have what we refer to as zero-shot forward transfer, which is the inverse. So we evaluate task I before and after training on task J, where J is an earlier task. So this allows us to see how much J is causing learning in I before we even see I. We can then analyze these in 2 separate ways. First, we generate a summary table, which aggregates over all of the tasks, and this allows us to see at a high level how well we're performing. We also get diagnostic tables. So we can look very specifically at how much one task is impacting another task. In this case, how much each column's task is impacting each row. So we can see, for example, whether training on dodgeball is causing forgetting in climber. This is very helpful for algorithm designers to see where particular failure modes are occurring, as well as for experiment designers to see if we're seeing the for transfer or forgetting that we're trying to analyze for. So yeah, if any of you are working on continual reinforcement learning methods, I hope you consider CORA, and we would love for you to reach out if you have questions or want to contribute.
Okay, so when it's doing the testing on other tasks, does it freeze the policy or running or anything, or does it allow when you use that
yeah, so the question is, when we're evaluating on tasks while training existing tasks, how are we doing that, basically? Yeah, so basically we are currently pausing training and then running 10 evaluation episodes on every task, and we're doing that periodically. How frequently we're doing it depends on which benchmark it is. Correct, yes. It is actually, yeah, actually don't know if it's currently in the code base to set that, but it is definitely doable. It's basically, yeah, exactly, pull request away.
So you said the framework is exclusive, right? So how easy is it to, let's say, add a new continual RL task?
A new continual RL task, yeah. So let me go to our, we specifically separated out policy implementations from experiment implementations to make it as easy as possible so that you can compose them as freely as you like. And so creating a new experiment is really easy. If you're doing something that's image task based, it's literally just a couple of lines. You import your what your environment is, and then you specify how many time steps you want to train each one for. And then similarly, if you want to implement a new policy, we have an API and you just implement it, and you can import existing code in, and we tried to make it as easy to do as possible.